Hello everyone. Myself Sucheta Yadav, Assistant Professor, Department of Applied Sciences and Humanities, ABES Engineering College, Ghaziabad. My today's topic for discussion here is Poisson distribution. Outline for my discussion, definition, assumptions of Poisson distribution, parameters of Poisson distribution, its mean and variance, and some questions appeared in various competition exams based on Poisson distribution. Now, Poisson distribution is a discrete probability distribution which gives probability of a given number of events happening in a specified time period. Now, the probability distribution for a Poisson distribution is given by P of x equals to r is equal to e to the power minus lambda, lambda to the power r upon r factorial, where r takes value 1, 2 till infinity. Some examples where Poisson distribution can be applied are telephone calls per hour at a call center, number of arrivals at a restaurant, emission of radioactive particles. Now, some assumptions of Poisson distribution are the events should be independent of each other, the rate of events through time should be constant, and the occurrence of events should not be simultaneous. The Poisson distribution can be considered as limiting case of binomial distribution. N and P are parameters of binomial distribution. Now, when n is very large, that is n tends to infinity, and P is very small, that is it tends towards zero, such that n into P is finite, then we can consider Poisson distribution as limiting case of binomial. Now, the parameter of Poisson distribution is taken to be lambda, which is given by n into P. Now, the recursive formula for Poisson distribution is given as P of x equals to r plus 1 is equal to lambda upon r plus 1, P x equals to r. Now, how we can use this recursive formula? In case P of x equals to 0 is given, and we have to find P of x equals to 1, 2, so on, then we can use above formula by putting r equals to 0 and so on. We can get the values of P of x equals to 1, 2, 3 and other values. Now, mean and variance of Poisson distribution. Mean is given by lambda and variance of Poisson distribution is also given by lambda. That is, mean and variance coincide for a Poisson distribution. Now we take some questions which have appeared in various competition exams based on Poisson distribution. The first question says that if the probability that an individual suffers a bad reaction from a certain infection is 0.001, what is the probability that out of 2000 individuals, more than 2 suffer a bad reaction? Now, why we can apply Poisson distribution here? Since n is very large and P, the probability that an individual suffers a bad reaction, is very small here, 0.001. So, Poisson distribution can be applied. So, for applying it, we need the value of lambda, which is given by n into P. And n here is 2000. And P is given by 0.001, which will give me lambda as 2. Now, he is asking you to find the probability such that more than 2 individuals suffer a bad reaction. That means he is asking you to find P of x greater than 2. Now, there is one property for probability distribution that sum of all the probabilities is 1. We can use that property to find P of x greater than 2. We can write it as 1 minus sum of P of x equals to 0 plus P of x equals to 1 plus P of x equals to 2. Now, how to find P of x equals to 0? P of x equals to r for Poisson distribution is given by e to the power minus lambda, lambda to the power upon r. Now, P of x equals to 0, we will take r as 0. So, e to the power minus lambda, lambda to the power 0 upon 0 factorial plus e to the power minus lambda. Now, we'll take r as 1. And for P of x equals to 2, we will take r as 2. can put the value of lambda, which we have found to be 2. So 1 minus e to the power minus 2. Now lambda to the power 0 will be 1 and 0 factorial will also be 1 plus e to the power minus 2, 2 to the power 1, 1 factorial is also 1 plus e to the power minus 2, 2 square upon 2. Now when we'll solve this, we'll get 1 minus 5 times e to the power minus 2, that is 1 minus 5 upon. Now when we take our next question, says that if a random variable x has distribution with mean 5, then you have to find the value of this expression. This expression is expectation of x plus 2. Now it is given that this random variable x is having Poisson distribution and mean is given by 5. So we know that mean of Poisson distribution is lambda, so we'll take it to be 5. Now to find the value of this expression x plus 2 square, expectation of x plus 2 square, and I open the square, I'll get e of x square plus 4x plus 4. Now using the properties of expectation, I can write it as e of x square plus 4 times e of x plus e of 4. Now e of x is given by the mean and variance is given by e of x square minus e of x whole square. Now since we know that mean and variance of Poisson distribution coincide, so mean is also equal to 5 and variance is also equal to 5. So e of x square and e of x is given by mean. So e of x square will give me 30. Now I can substitute these values here and I will get 30 plus 4 into 5 plus now e of 4. Now there is one property in expectation that e of a constant is equal to constant. So we can use it and it will give me 4. So I can find it to be 30 plus 20 plus 4, which will be. So the value of required expression is 52. Now third question says, consider a random variable to which Poisson distribution is best fitted and a relation is given which says that p of x equals to 1 is 2/3 of p of x equals to 2 for this distribution and we have to find the variance. Now since we know that probability for x equals to r for Poisson distribution is given by p to the power minus lambda, lambda to the power r upon r factorial. We can use it here for p of x equals to 1. I'll put r to be 1. We get e to the power minus lambda, lambda to the power 1 upon 1 factorial equals to 2/3 e to the power minus lambda. There I'll put r to be 2 upon 2 factorial. I have to simplify this. So minus lambda into lambda equals to 2/3 lambda square e to the power minus lambda upon 2, which on simplification will give me 1/3 lambda is equals to 1, which gives lambda. This is the required value for lambda. It is asking you to find the variance. Since we know that mean and variance for Poisson distribution are same and they are equal to lambda. So I got variance is equal to 3. This is the required solution for this question. Some books which you can refer for studying this topic are these two, and other books also you can refer. Thanks for listening.